Alright, in this picture we see we have a kind of a plane region. It's defined as all values of z are equal to x plus y, and basically we're going to try to find the volume. In this example, we're going to try to find the volume underneath this plane region, and it's going to be between this rectangle that's defined as the lines of x equals 2 and y equals 2, which you can see in the red.
We are going to start by taking a cross-section of this prism, which is shown in blue. This cross-section is perpendicular to the y-axis. We are then going to find the area of the cross-section using integration.
Here's a more comprehensive view of this cross-section we have selected to find the area of. Now we should look at this as a normal integration problem. The bottom left is like our first round. This point is x equals 2, and we can call this y value b. The bottom right, we know that x equals 0 because it is on the y-axis, and since this cross-section is perpendicular, we know that y is also equal to b. Notice that the top of this cross-section is defined by our initial function z equals x plus y. Let's integrate this function from x equals to 0 to x equals to 2.
To find the area under the curve z equals x plus y in this little section, the y values are defined by x plus y, so we will have to integrate this. We must integrate from x equals 0 to x equals to 2, and multiply it by dx to find the depth of the cross-section. To begin the integration process, we must separate the x and y and multiply dx on both sides. The left integral we can use normal integration process. The integral on the right, though, is not much different. Since across this section y values are the same on both points, y equals b, we can simply keep y as a constant. When you integrate this, the integral becomes y times x.
So what we have just done is we have just found the area of one cross-section that is perpendicular to the y-axis. Basically, this integration formula, which you see at the bottom, can serve for any cross-section that is perpendicular to the y-axis. It doesn't matter which cross-section it is, you will still be able to find the area with this simple formula. Now we will look at how to find the volume using these by adding up these cross-sections with another integration. Well, we just found area of one cross-section, so now let's find the volume. Basically, what we're going to do is we're going to add up all of these cross-sections using integration. Each cross-section is defined by one y value. So if we take all of the areas made up by each y value and multiply them by a small change in y, we will be able to find the whole entire volume. So basically what we're going to do is we're going to take the integration of these areas and multiply it times a little change in dy across the interval 0 to 2.
Basically, we found the definition of the area of cross-sections and then added these areas up to find a volume. The integral on the inside represents the cross-sections, while the integral on the outside is the sum of the areas of the cross-sections. This shows how double integration is used to find the volume of an object.